Right. So, hello everyone, and thanks for joining us today for today's presentation. My name is Andres Velez. I'm the product manager for the AutoTURN family of products here at Transoft headquarters in Richmond, BC. And today, I am very excited to share with you the new release of AutoTURN and AutoTURN Pro. This is version 11. And this version has a lot of new features that will help you accomplish the design challenges or the current design challenges that everyone or a lot of our users are currently facing. Before we start, a couple of housekeeping items. This webinar is being recorded. After the webinar, you will get a link with the recording of this session. If you want to share it with colleagues, collaborators, or stakeholders, feel free to do it. We will have a questions and answers section at the end. But if at any point in time during the presentation questions arise, feel free to enter them in the questions section of the GoToWebinar interface. I'll do my best in responding to each and every of these questions during the webinar. But because we have a large audience today, about 500 people, if I don't get to answer all of your questions, we will get an email, follow-up email with the answer to your questions. And last but not least, we will have a survey that will be launched at the end of the session. These surveys, for those of you that are not aware, are very helpful for us in terms of learning more about, well, get your take on the webinar, where the information presented was relevant or not. If you have any comments or suggestions, those are great, and we're always listening to our customers. So any feedback is very valuable to us, so please complete the survey. And now let me talk to you a bit about the agenda for today's presentation, because we have quite a few things to cover. So I will start by giving you, as usual, a little bit of background about Transoft. A couple of things have changed recently. We keep growing and expanding, so I will update you on that. I'll share some of the highlights that have made AutoTURN the industry standard. And as you know, it's been the industry standard for swept path analysis and the preferred solution worldwide. So I'll share with you some of the reasons why, and then we will jump right away into version 11, where I'll share the top tools you'll find there in the software, how can you take advantage of them. I'll share part of or some of the motivation behind these tools, so on and so forth. And again, if at any point in time you have any questions, feel free to enter them. All right, so let's begin by talking a little bit about Transoft and what has changed recently. And as you can see here, we keep growing, we keep expanding. We have acquired new products and new offices around the world. And what that means to you is, of course, more solutions to address your design challenges and better support. Although our product support is top-notch. For those of you that have tried it, you know we have very short turnaround times. But as you can see, we kind of like have a good coverage worldwide. North America, even Latin America, Europe, and Australia and the Pacific. We have offices everywhere. And now let me share with you some of the key aspects that make AutoTURN the industry standard. And one of our top elements is our collaboration with industry experts and policymakers. We've been collaborating with AASHTO since 2004. We helped them develop the training templates in the Green Book 2011. We're currently working with them for any potential changes to the AASHTO Green Book. We do a similar task here in Canada with TAC and FHWA as well. And with TRB, we have presented our findings and all of our software development and the new tools in the software involve a lot of research and development, and we share all of these findings in the annual conference, TRB in Washington. So we have published there a couple of times, and whenever we have news to share, we will definitely be publishing there and trying to present at the annual conference. And we also have a good relationship and collaboration with ITE and CITE. And we try to replicate that worldwide. So in Australia, we have a strong connection with Ausroads and Big Roads, same as well, the European part, BAST in Germany, Kroll in the Netherlands, and Sweden. So again, we collaborate with all of them. We help them develop turning templates, and you'll see a lot of AutoTURN in their design guidelines. Now, when it comes to private firms and consultants, you can see how Transoft products have been widely accepted. And we're very happy and proud to see that each of the top companies in each of these segments that you see on the screen use AutoTURN or AutoTURN Pro. And this is a real proof of our commitment with the industry, and a lot of people will trust the outcome of the software, and that's why we keep improving, keep adding new functionality in our product. Now, AutoTURN, as I mentioned before, is the industry standard, and we think it's due to three main reasons. The first one, of course, is our product support. Those of you that have used it know we have very short turnaround times, knowledgeable people answering and helping you address your design challenges. That will be the first one. The second one, of course, or maybe this would have been the first one, is the accuracy of the software we provide, and we always generate reliable results that are realistic. Also, we won't let you do things that will exceed any of the vehicle limitations, including the speed. But the third one is our innovation. And as you can see here in this picture, it's these are all the releases since 2014 when we launched AutoTURN 9. And for each release, we keep innovating and adding new tools to accomplish other design challenges. But we also improve our existing tools to, well, fix bugs or maybe enhance capabilities, as you can see across the board here for each version. And this takes us to AutoTURN 11. Of course, the innovation will continue, but this is what separates us from our competitors. We keep innovating. We are committed to our subject matter. We are the experts. And now our main interest is to provide you with the best set of tools to keep doing your work and face new design challenges. So these are just the top 5 features for each release. There's more, of course. These are the ones that are worth mentioning here. And now for version 11, as you can see, we have a couple already listed there. But let me give you now the full list for AutoTURN 11. Oh, sorry. So this is what's new in the 11th version of our software. As you can see, the top 3 features are definitely going into the Pro version of the software. We are adding the ability to simulate bicycle maneuvers, and I'll walk you through, well, first the motivation behind developing this tool and why it has to be a different or a separate tool. You cannot just take a regular vehicle and pretend it's a bicycle, even though you could potentially configure it. The second tool is intended to help you understand better the simulations you're creating. There's a lot of uncertainty, and with this tool, our intention is to help you identify some critical aspects of your simulations, how they influence their design, and ultimately, because you will use your design judgment, to make sure your project and the simulations for your project meet your design criteria. This tool will help you identify some of these critical aspects and let you know how they're influencing sweat path, or where are they taking place in a simulation, so that you can be aware of them and make sure they meet your design criteria. And the third one I'd like to mention at this point is IntelliPath. We completely changed this tool. The core function is still the same, but now it's an easier and better way to actually use the tool. So you'll see more of that. And let's go now to the next couple of tools. Although, well, vehicle libraries, as you can see, we're adding more manufacturer vehicle libraries, and as well as standard vehicle libraries. And that will give you the most comprehensive database available in the market for all kinds of vehicles. All right, so let's talk first about the new standard vehicles that we're adding for this version. You know, for each version of the software, we make a lot of efforts in checking guidelines, make sure our libraries are up to date, and if they're not, we'll update right away. And for this version, we have new vehicles for Florida DOT according to their highway design manual. Similar case for Caltrans. There's been some changes to their design vehicles, so we have those now. We recently added those into our database. Some updates for Canada as well. Some covering provinces, 2 for Alberta, and then specific vehicle guidelines for cities such as Toronto, Quebec, and Vancouver. Those you will find also in the software in both AutoTURN and AutoTURN Pro. And of course, for those of you that are interested in international guidelines, if you have projects outside your country, then we keep adding content for Europe, UK, Sweden, and then Australia as well. And those are all libraries that have been updated. And now that we have covered libraries, let's go and let's jump into our new tools. So the first tool that I'd like to show you and share with you is the bicycle simulation tool. As you know, in North America, the Vision Zero and the Complete Streets policy are driving a lot of design projects that are trying to make streets safer for all users and also user-friendly for all users, not specifically motorized vehicles. And that a lot of times involves the design of on-street and off-street bike lanes. And this design guidelines will give you a good set of rules, but there are times where designers need to deviate from the design because, well, from the design guideline because there are situations that you cannot avoid. Sometimes you cannot just, you need to go around a building and you don't have enough space, or you have more complex turns, and then the ultimate mean to figure out any potential issues for vehicles and bicycles is to, well, check some maneuvers. Also, if you're trying to attract new users to your bike lanes, which is one of the measurements of success, you really want to be sure that your bike lane design can be used by all sorts of bicycles, not just the standard bicycles. And all the examples you see currently on the screen, we took them from New York City DOT. They're pretty great at illustrating all these cases. They all pose challenges, not necessarily for standard vehicles, but or for the standard bicycle, which is quite flexible and maneuverable, but for other vehicles that are slightly larger, or cargo bikes or bicycle pulling a child trailer. So all of these can pose potential challenges to all of those. And if your goal is to attract these people, if your design can accommodate them safely and comfortably, then you'll be doing a great job at designing it. Otherwise, yeah, well, the success might not be as high. So so that's part of the motivation, all these projects, and Another portion of the motivation for adopting all these policies is make our cities more sustainable and move to sustainable means of transportation. So because of that, we were approached by a lot of customers, including consultants and cities such as City of Auckland, Sustrans in the UK, City of Vancouver here. We have talked to Seattle, and they are all incorporating all these projects into their designs. And at some points, they all need to will make sure they will work not just for the standard bicycle, but for other standard bikes included. They approached us. We, of course, realized that these vehicles cannot just or cannot be just replicated by the current algorithm. We developed a new algorithm based on the design guidelines, and now AutoTURN will allow you to simulate bicycle maneuvers. So now that we talk a little bit about the differences, let me just emphasize a little bit more and walk you through this. The two main differences are the behavior, how these vehicles behave. So they can steer as a motorized vehicle, but they also lean to steer or help the steering, as you can see on the video that's playing here. And as this vehicle lean, the envelopes and the what we call here the rider's box, which is what represents the rider, will describe a different envelope than what the vehicle will do. That's why you cannot just simply take, say, a car in AutoTURN, make it narrower and use a single wheel in each axle and use that to replicate bikes, because you won't get a true envelope, or the envelope won't be true because you won't be accounting by the rider how the vehicle leans when it makes the turn. And you can see here the rider's box. This is something that's defined in pretty much all the guidelines we came across, and it's intended to define the extents of that rider. And unlike regular vehicles or motorized vehicles, in many of the bicycle or cycles, the rider is part of the chassis of the body, and it describes envelopes, as you can see on the screen. All right. Now, just to emphasize a little bit more, this is kind of like the behavior you will see on a bicycle. You can see the rider's box there, and you can see what happens when the bicycle leans to make the turn. Essentially, the clearance, the width clearance it increases, and of course, depending on the height and the width of the rider or the rider's box, then you will get different envelopes. Now, let's talk a little bit about the types that we support for this tool. And we support a wide variety of bicycles, going a little beyond of what, for instance, the AASHTO guideline indicates as the standard vehicles. And the reason for this is because we know all these alternative and sustainable means of transport are a new trend, essentially. And we are seeing more, for instance, mopeds and scooters being adopted as a short distance means of transport. So we added those into the software if you are interested in checking them. And overall, we have 13 types, including just single unit bicycles, or like the regular bike, and bicycles with trailers like the child trailer or cargo bikes. These are common in other countries. But again, if you're looking at attracting new markets, and delivery using bicycles is also a trend nowadays. So if you're looking at making sure your designs can accommodate from cargo bikes or all sorts of cargo bikes, we have those in the software. They're part of a Transoft library of bicycles, those that are not included in any design guideline, and the ones that are included, then you can search and look for them in the software. Of course, as I mentioned before, in the case of North America, we do support the bicycle design vehicles included in the AASHTO guide for the development of bicycle facilities. So these bikes you see here will be part of the AASHTO bicycles guideline. And we also cover the Canadian guidelines for bicycle design and the Mexican bicycle design guideline. So North American continent is pretty much all covered. We also support Australia with their design guideline. Again, if you're interested in looking at different types of bicycles that you might see arising on your area and you want to make sure they are there, you can use these ones, or based on these ones, create your own custom ones. If you are a city and you have your own subset, feel free to contact us. We'll be happy to help you create these vehicles in the software and support you in that sense. Cities, DOTs will be happy to address your needs and help you develop these guidelines. And last but not least, in terms of bicycle design, and you will see a technical demo of this tool, we also have some European guidelines on design vehicles. Those of you that are not aware, this particularly Netherlands and Denmark, they're leading all the bicycle infrastructure design at the world stage. So we also incorporate their guidelines and whatever vehicles they have observed already as critical vehicles in those design guidelines. So these are also supported. You'll find them there in the software. They're quite easy to find. I'll share with you how. And let's jump into our next tool. This is just to introduce you to the tool. And our next tool, as I talked in the introduction, is the spec simulation tool. What we have heard from our customers and we have realized through our tips, webinars, and every kind of like live presentation we make is that there's a lot of uncertainty about how simulations were created. When you're performing peer reviews, when you're checking drawings submitted by a consultant or a third party, or even when you're just trying to learn about these parameters in the software, there's always a lot of uncertainty because the software is very easy to use and it seems very straightforward, but some of these parameters are question marks and they do play an important role in vehicle simulation. So the inspect simulation tool is intended to help you make sure these parameters that are key and should be part of your design criteria are met by the simulations created. And some of these parameters are listed here. And to quickly illustrate this, you see the graphic on the left right now, the image we're displaying at the moment. And you see two simulations, two semi-trailers with a 5-foot clearance. So apparently everything looks fine for these two vehicles. They seem tight, but it's just the clearance that it's tight. The rest seems to be fine. So in theory, these two vehicles won't have any issues at turning in this intersection, when turning at this intersection. But when we run the report, if we're looking at the speed this simulation was created, it's highlighted in red because the speed was too low, was between 1 and 10 miles per hour. And that's fine if a vehicle comes to a complete stop. But if the vehicle, in this case, gets the green light, then the speed should be higher. And the picture or the image you're seeing in the right is using a speed that goes between 11 and 20 miles per hour, which is closer to what the vehicle will do. And now we start seeing the envelopes are a little overlapped there, which means we're not meeting our design criteria. And these are the kind of aspects this tool will help you address. And again, you'll see this live on the demo, how it works and how to use it. But this is to quickly illustrate and give you some background of how the tool works. And last but not least, IntelliPath, which we have, it's a tool that's been out since version 10, essentially, so about 2 years. We have heard from a lot of our users that the concept is very, very valid. But for this version, we did a complete overhaul of this tool to make it more user-friendly and easier to use because the value that this tool brings to the table is huge, as we have heard. It helps you solve all the possible paths based on the available space. It does that automatically. So instead of you driving the vehicle to figure out where it can go, or the tool will figure that out based on the space that you define as available for it. It will let you calculate maximum allowable speed, so also tied to street designs. If you are doing traffic calming and want to see how effective that traffic calming is at reducing speed while making certain vehicles or while keeping access available for certain vehicles that you still need to grant access. The tool will give you that. And of course, as I mentioned before, it saves all this time through automation. It allows you to swap vehicles. So once again, the concept of the tool is still the same, where you essentially just define where you don't want the vehicle, like the drivable areas, the route, and then the points that you would like the vehicle to go through, and we automatically generate the path in the background, trying to follow, the trajectory you indicated. So let me walk you quickly through what has changed in the tool. It still comprises of 4 steps, but it's changed in this sense. You define your analysis area simply by clicking on the points where you want to create your simulations. Then you can use the window pick to select multiple elements at a time, as you just saw. And then once you've done that, you create your route and you edit your route right away. You can fine tune it. You'll see that on the technical demo in case you missed it. And then you just generate your movement by clicking the start and end points, and then okay. So with that, let me jump into our technical demo. And I'm going to start with the first tool that I talked to you about. And what we have here is we have 3 scenarios here that we're going to quickly check for different kinds of vehicles. We have a protected bike lane intersection, quite common in New York. It was developed first in the Netherlands. So we're going to check a couple of movements for that with some key elements in mind. The second one is a 90-degree turn. This one is a level turn where bicycles are actually crossing the road at the same level. But if you have, for instance, an overpass and you're sizing ramps and these turns to go over, for instance, the highway, you could also, or you'll be also able to relate to this scenario. And our last one, which is also pretty common, are bypass bus lanes for bike lanes, where the bike lane will go behind. And in those cases, when you have 2-way bike lanes, if you don't have enough clearance, your oncoming traffic might get too close to comfort. And these are things that are important if you want to keep the sustainability of your project, and you want to keep your project being efficient. So let's start with our first intersection. Let me just switch to a single viewport. That will make my life easier and will give you a better view. Okay, so let's start. We went to the wrong one, of course. So let's start with our first. So a lot of guidelines and some of thumb rules when you need to deviate from design indicates that you could use, or you should use, a 10-foot radius for this type of turns. I'm just going to measure the one we have here quickly, and this one's about 6-foot radius. It's not very big, and yeah, let's create some simulations here so that you can see the effects of leaning on the bicycles and the effect of on the path. So we're going to launch our vehicles just as we always do in AutoTURN. And I'm sorry it's taking a little bit because it's loading a huge database. I'm going to refresh my filters, and you can see this already changed. So what it's doing now is just refreshing. We have over 2,000 vehicles now in the software. That's why it's taking a bit to refresh. Plus, I'm sharing my screen, so it takes a while, and some of my video card I'm going to clear all. And then a couple of things. All of our libraries I'll steer here. You can still find them the same way you used to do it before, just by clicking or checking. If we clear them all, we can also search. So what I'm going to do is I'm going to type bicycle because I want to see all the bicycles we have available. And now this is going to apply that filter. We see all the bikes that we have. In this case, I had the North American or the one from Ashton selected. So it's showing me that one first. You can see the Transoft library here at the bottom. And we can use a filter and just say, okay, I want to see what bicycles we have for the US. And here are the Ashton design bicycles plus one from the Transoft library. Now, this is new in version 11. It's available in both AutoTURN and AutoTURN Pro. Just quickly walking you through what you can do, because the other functionality that we have here now is the ability to set up groups. And for this webinar, I did set up a group. So the way to find the group that I set up, the way to add vehicles is through this button, but the way to find my groups is here. And then if I go here and clear all, and then just use my vehicles for the launch, this brings my subset for this presentation. And I have my bicycle here. I'm going to say OK to that, and I'm going to start generating a simulation for it. So if I say OK, I click on the SmartPad tools. I get some controls to change my design vehicle and still to be able to align it with geometry. I can use that functionality. And I have my bike now attached to my cursor. You can see the rider box in blue and our bicycle similar to AutoTURN control from the steering wheel. Now I can set offsets for handlebars, pedals. I'm going to turn that off because again, I'm sharing my screen, and it's going to take a lot of resources from this machine. And we simply drive. So a couple of things that you may have noticed. We do have controls for superelevation and lateral friction that will influence the turn, same as they do for motorized vehicles, but the coefficients are different. Same as before, we can click to generate the first section there for the first turn. And you can see now that I'm turning, the bicycle is leaning towards the left. And now if I'm going to make the right turn here, and I'm doing it at 10 miles per hour, so I may not have to do the transition. And you can see it's perhaps too tight for this speed, so I could change the speed and lower it down, say to 6 miles per hour, for instance. And of course, that's going to have an impact on my simulation. And of course, this is a standard bicycle, so likely we won't have many issues for it. I could also use corner path for it and guide my movement using geometry to make that turn. And you can see, well, this one will likely be able to do it without much trouble. We can accomplish the turn we're looking for. It's pretty tight, but then what about other vehicles? This one is coming in too close. Of course, we're not following the recommendations. So if we increase this to 10 feet, this bicycle might not have any issues. But let's see how this design could be challenging for other bicycles using this infrastructure. So if we're looking at a bicycle with a trailer or something that will generate or have more off-tracking due to its length. So if I switch to this one, again, I can use the same tools to help orient my vehicle at the beginning. I'm going to keep the speed low. And then I'm going to generate my first section, say up to here. And I'm going to place it there. And again, if we had, say, a median, we could use the offsets and check clearances to it. So you want to make sure our pedals don't hit the curb. We can set up clearance, and we could say, okay, I want to use 0.5 feet, 5-foot clearance for this bicycle, and then I can switch to corner path. Now you can see the envelope being displayed there. And I'm going to pick some geometry to kind of guide the movement here and see whether this one can make it. And because we have a larger off-tracking, it doesn't seem too bad. But you can see if this person was to make this turn comfortably and without leaning too much, he'll run into trouble there with the sidewalk. He can come close, or he'll come too close to one side or the other. And if he's not an experienced rider, then it might run into certain problems. You might brake a lot and slow down your bike lane design. So this is a good example of how two vehicles can have different challenges when making turns here. We could use a cargo bike. I'll use it in the other example just because I don't want to spend too much time. And here we're going to see what happens if we need to have back-to-back 90-degree turns. For this, I'm going to use the twin bicycle, also from the AutoTURN design guide. All right, so let's do it quickly here and make the turn. And again, I'm going to use corner path in this case. It's easy. I can get my bicycle oriented like this. And then again, we can place it there and see how the turn will go for this guy. See if we have enough space to comfortably accommodate this bicycle. And you can see, let me just turn off the offsets. Here, for instance, if this was a ramp and an elevated cross, we could use the handlebars to check clearances against railings. So let me, sorry, my mouse is going all over. Okay, we're good to go. So if we're making this turn, you can see right away, okay, this guy is going to have some trouble making the turn there. We can still change the center line radius, make it go a little wider, but this illustrates the point if you're checking clearances. So hopefully you get a good sense of how this tool works, how the lean is influencing the turn, and how it's not just your off tracking, but the lean influencing the envelopes. And last but not least, I'm going to check a couple of vehicles quickly here and some clearances, for instance, for the handlebars. So first, I'm going to use a cargo bike. This is not part of the ASHA guideline, but this is a quite common type of bike, especially if you're looking at, attracting new users and different users to your bike lane design. So let's say in this case, we're going to use or check this bypass lane, going behind the bus stop. And again, I haven't changed much the speed, but we can see this one, because it's a lot wider, is having a lot more issues. And we might not be able to make or to have a good clearance for this type of vehicle and the oncoming traffic. If we had two of these, then it would be pretty obvious that we need more space to safely drive on. So sorry, it's a little slow. That's why I'm clumsy driving it. And if we have a bicycle coming over on the opposite direction, and I'm just going to use the tandem bicycle, then you will see that they come in really close. So in all these cases, one, we deviated from the design. In the others, we have some tight designs due to tight situations, and these are pretty good examples of when to check bicycle maneuvers and bicycle movements to make sure you have enough space, because it's when you need to make this kind of more complex turns, or when you have space limitations, that you want to make sure all your design vehicles can navigate through the infrastructure. So if I click there, and then I'll try to make it go around, you can see it's coming pretty close. So in this case, well, this guy will have a little more maneuverability, but if we were looking at clearances to the handlebars, then this might be too close to comfort. And AutoTURN allows you to customize bicycles, but again, if you're interested in creating your own library and you don't find the vehicles, or if you want to learn more about, please contact us. We'll be happy to help you. Bicycle definition is similar to any other custom vehicle definition in AutoTURN. You just pick the one you want to use as base, and when you make a copy or create new, you will have the dialog to enter all the relevant information for your bicycle, as you can see here, including the rider box. So all the widths, pedal heights, all the aspects that are relevant for bicycles. So even though they look simpler, they're not simple at all. They're quite complex to model. That's why we have enabled all this in the software. So with that, let's jump into our second tool that I'd like to show you today quickly, and that is the Inspect Simulation tool. And similar to what we saw on the slides, we have here a situation where we receive this from a colleague and our partner, third party, and they all look okay. They all seem to have enough clearance. But when you receive this, you will look at the envelopes first, and then you won't really know if there's anything wrong. They look correct at a glance. So the Inspect Simulation tool, which you'll find here in the menu, will let you check multiple aspects of your design, including the steering angle. In this case, it might not be the most relevant parameter because you likely won't get anywhere near the steering lock angle of the vehicle. But for cases where you're looking at tighter turns and space availability, you may want to check the steering lock angle. The input speed will be definitely relevant for us because if these simulations were created at a too low speed, then the real life situation might be a lot tighter. And you will see that here. We can also check for the maximum speed, and for those of you that don't know, there's a difference between the input speed, the speed that you use to create the simulation, and the speed the vehicle can actually make following that path. So it allows you to check the maximum speed. We'll check for proximity against other elements. Those can be also vehicles, so we'll check on that. In this case, it will be very meaningful to see if the turn wheel stop behavior is on or off. Those of you that don't know, the turn wheel stop is only recommended for very low speed simulations where the driver comes to a complete stop and cranks the wheels in the opposite direction or corrects the steering kind of drastically, almost on the spot. And in this case, it won't be realistic if these simulations were using that because the driver is not going to come to a complete stop here in the middle while making the turn and then changing direction. So if the tool was used, we should definitely check for it and see if we get a warning. So with that said, let's inspect the current simulations we have here. And simply by clicking, you check the parameters first, and then you pick the simulation you would like to inspect. And remember, the speed that I have set is everything that's between 1 and 6 miles per hour. I want to give me, or I want the software to give me a warning. And if I'm using the turn wheel stop, I also want the software to give me a warning. And in this case, it's giving me a warning saying, hey, the simulation for each of these sections was using that. So even though it looks correct, the base or the creation speed might not be the right one for this turn. If the vehicle is coming to a complete stop, sure. But if the vehicle gets the green light, then we might run into issues here. And we can check the second one for the same criteria and get essentially the same results. Now let me quickly show you simulations created at the right speed. So I'm quickly going to delete this. And just to illustrate, I'm going to turn on my 2 simulations created with the right speeds. And as I turn them on, you'll see now, okay, we'll run the report on this too, but you can see already how they're taking a little more space, right? We have some overlaps there. So what I'm going to do now is just turn off the old ones, the ones that were created using the wrong criteria. And run the report on these ones. See what speeds we get. Of course, now in the case of the WB40, we have an overlap here. And it's touching the articulated bus. And that will let me show you something else. So now we, again, want to check our speeds. What I'm going to do is I'm going to increase this a little bit because 7 to 12 might also be too low. So I'm going to change this, say, 10 to 20 miles per hour. We're going to get a green notification if that's the speed used. That seems reasonable for a semi-trailer making this turn. And I also want to check for proximity. And proximity has changed for this version of AutoTURN. We can do conflict detection with multiple levels or layers. In this case, I have a simulation using the A-bus layer. So I just want to make sure that I have it checked here, and it's checked. And now I'm going to run the inspect simulation tool on my new simulation, or the simulation we're currently displaying. And it's again, calculating and looking at each section. And we got a green for sure. For proximity, we have, if it comes, well, let's say we can change proximity here. So what I'm going to do is I'm going to get a red warning if this is 0. And if I'm within 3 feet, although it should be 5 feet, I need to get a notification too. And I'm going to reinspect. We now know that our speeds are correct and the simulation is not using turn wheel from stop. All right. And we got a notification now here on the conflict. So they're overlapping and we're getting the warning. Of course, I set up the wrong parameters. This should have been slightly bigger than 0. That's why I got the layer confused. So just let it there. But we can do proximity to our simulations, make sure they meet our design criteria. These are just some of the parameters this tool will allow you to check. Again, depending on the scenario, you may want to check certain aspects. But in this case, the ones we wanted to check for sure were incorrect behaviors. The tool will give you a summary here of what's desirable. And that way, you can make sure the right criteria was used to create the simulation. I'm going to save this and move on to our next one, which is for IntelliPath. Although you have seen other elements or other features that are new in the software, like properties and search for vehicles. Now, let me share with you some of the improvements we have made for IntelliPath. The core function is still the same, the objective is still the same, but the setup is a little faster now. So let me quickly walk you through it. You start again by defining your analysis area, but now instead of having to draw anything or picking something you pre-draw, you can simply draw it yourself, kind of. So if I want to go just this box here, I right-click, and that's it. That's my analysis area. Now, a couple of things that I should have made and I haven't done yet. I'm going to turn off some layers. So, sorry. Now we have seen the hatching, we get the general sense of what this site is. For now, I don't need to see my lane lines. So I'm going to turn off these 2 layers. And the next thing, again, is defining your exclusion lines. And for that, we have implemented the window pick functionality. So I can go ahead and, if I'm using layer control, pick a whole bunch of things in just one go. And then pick, well, whatever I didn't pick on my first one. But you can see how it's a lot faster now. And yeah, just please bear with me and my video card. It's suffering a little bit. But you can see how quickly I'm picking all the exclusion lines. All right, and we're all pretty much set. We have picked something that will give us some routes to go around this site. This is a hospital, so we'll be checking some vehicles here. If I do the right click, that geometry is now being incorporated into my site. This is just taking a little bit to calculate and adding it into our site. And again, some of this is because me sharing the screen. All right, so we picked our geometry. We're good to go. What I'm going to do next is I'm going to turn on, my my lane line geometry, because I need to help guide the movement. So I'm going to turn this layer on, and we're good now. And now the next thing is define our route. So for our route definition, I'm going to go here from the bottom. And you can see now it's hatching there. Let's say we have an ambulance coming in and out of this area. So I'm just going to make it go around. And then let's make it go all the way up here, just to generate a movement with lots of turns that will be quite challenging to make using the SmartPath tools. So we go up to there, and once we have defined our route, we switch to what we call editing mode. So this is my current route, but I know I don't want vehicles to use all 3 lanes to make turns. So I can define how I want them to follow this. So let's say from the beginning, so for this stretch of the road, I want to use my right lane. And I get this dialog here that will let me pick elements in my drawing. And you can see how smart it is. It's going to pick geometry that I have there and it's going to snap to it. So now I have my route defined there. I want to do the same, let's say from this point to this point, I want to use the right lane. So I'm going to pick another element here. Oh, I'm sorry, it switched. So I can always go back and edit. So once again, from this point to this point, oh, sorry. I want to pick an element. And I want to pick this guy here. All right, so it recomputed that. And now from this point to our lane, I don't have any geometry there. If I had it, I could use it, but now I want to use an arc. I'm sorry, this is just my video card. So if I click here, and let's do it again. So from here to here, I want to use an arc. Okay, and I want to make it a little smooth. This ambulance might be turning fast here, and now we can continue. So here we want it to go straight. So I just pick the segment that I want to edit and the points that I want my simulation to follow. I can do the same on the other side. So here, from here, say, to here, we almost want it to go on a straight line. So once again, I just click. And then from this point on, I don't want to have anything to do with the parking stalls here. So we can go on a straight line. And you can see how easy and intuitive it is to edit now and define the space we want to make available for this vehicle, or for the vehicles we want to check, because we can check multiple. So in this case, I'm going to do it a little quicker just in this area. And now we want to use the right lane. So what I'm going to do first is pick a segment here and say, okay, from here to here, I want you to snap to an element. Let's do it again. Yeah, there's some delay in my clicking because of the broadcasting, and that's why. But you can do all this edits at once. So it's going to snap to that. And we can say, okay, so from here to here, we want to use an arc. So let's do that again. And I was picking right, so yeah, let's do it on an arc from here to here. And even though it takes a little or a couple of minutes to set it up, once we're done, we can generate multiple maneuvers or swap vehicles. So, and I'm going to just do this last part. And I'm going to push it a little bit, make it go all the way, say, to here. And now let's pick an element. Yeah, it's because I'm clicking too fast. So once again, from this point to this point, I want to pick an element. And I just want to pick this guy. So now it's solving it. And one last one. So we got our route right. So from here to here, let's pick our element. And again, my clicking is not great. So from here to here, we want this to snap to geometry. And I'll just pick my lane lines. And these are just lines and arcs that are connected. We have our route now. And let's create movements. So of course I had a bicycle selected, and we don't support bikes for the IntelliPad tool. I'm going to change my speed to miles per hour. And then I'm going to switch to a different vehicle. And let's say we want to try first a small ambulance. And once again, I'm taking some of the time from the question section. So if you have any questions, feel free to ask them. I'll jump into it in a minute. Okay, so now we have our interface here. Let me generate a quickly a movement. So I'm going to start with a small ambulance here. And I'm going to say okay to this. I want to change my speed to 10, see if you can make it. And I want to use the body envelope for my ambulance and say okay. All right. And now another thing you see here is we can use geometry to orient the movement. So I'm just going to start here, somewhere over here. Pick this line, go forward. And let's place it, say, over here, right before the turn. And then I can make it go all the way until the end. See if you can make it through there, taking that loop, and then right click. And now IntelliPad is computing the pad. You can see it's pretty fast at doing it. And we'll see if this turn can be made. So right now it's just, well, calculating all these paths in the back. Yeah, and we got our simulation. So things we could do here, we could swap or we could add in our vehicle. Just for the sake of time, I'm going to swap this one, see if I can make it for a larger ambulance going around the same at 10 miles per hour. I could have the tool to calculate the maximum speed, but those functions were there before. So right now it's, again, let's bring up the dialog. And if you want to use a larger vehicle, so this one was 20 foot long. If I want to check a longer one, 30 foot long ambulance going around, then all I have to do is say, okay, and this will let me swap vehicles. If we want a separate movement, we can also do it. There's the add movement there. We get to confirm the speed. Oh, it switched to a fire truck. So this one is a lot longer. You might not be able to make it at 10. But it did make it. So we have enough space. Now, one last thing before we jump into our question section. If we had a larger vehicle making this turn, we can clone the route as well. We don't need to redefine a new route for a larger vehicle. We can just copy the route, give it a name, and edit the portion where we will allow for more space. So right now, what I'm going to do is I'm going to turn off the existing one. This is the new route. And then we can edit the route boundary and make it go, for instance, a little wider here. If we are looking at something bigger, say a semi-trailer. So this is how easy you will copy the route and edit for new movement or the movement of a larger vehicle. So with that, I would like to close this. Again, we're open for questions. I would like to share with you a couple of things before we go. So just bear with me for a second. Some of the tools you saw today that we are supporting in version 11, you can set individual layers and properties for every component of your simulation now. Before it was by category. Now you can put every single aspect on a different layer. We saw the search and set groups vehicle abilities. So those are there. They'll make finding the right vehicle easier. In terms of compatibility, we're of course compatible with the latest versions available in the market for Autodesk products, 2015 to 2020, both AutoCAD and Civil 3D for Bentley MicroStation, P8i SS10 and up, and Connect Update 12 and up, and then all the other variations for Bentley, the ones that support third-party applications, we do support them. BricsCAD and ZWCAD, those of you that use it, we're also compatible with the latest versions. Now, we're also offering, if you're interested in AutoTURN Pro, we're offering user and term-based licenses. For our current map customers, you will receive an email with instructions on how to access the latest version of the software. You will be downloading it through our new My Transoft portal website. So you will get an email explaining all that. If you have any questions, feel free to contact us and we'll be happy to address them. And now I'm going to open it up for questions. And And I'll try to address as many as possible. Small reminder, please fill out the survey at the end of the session. Okay, so we have quite a few questions. What is the most conservative type of bike to use? Well, in general, you have to look at the bikes and see which ones have a more conservative turn. If you're looking at off-tracking, longer bicycles will have, or bicycles pulling a trailer, they will produce more off-tracking. But keep in mind that the off-tracking also depends on the rider's box. So if you make your box too tall as the bicycle lean, you'll get a wider envelope. Does the analysis take into account grade changes, like if you're on a bit of slope, downhill, and turning? It takes into account super elevation for the turn, if you're talking about, well, both bikes and vehicles. So you could affect your simulation and the outcome of the simulation by changing the super elevation of the road. As of uphill and downhill, we don't account for it yet. Can custom vehicle loads be added to bicycles? Yes, we support adding loads. However, I would recommend you to just modify the bicycle parameters. If you're looking, for instance, a cargo bike, just change the width of the front of the bike, and that will give you a more accurate simulation than just a load, because the load is attached to the vehicle, but it doesn't lean in this case. Is there any way to preload standard speeds and offsets for both bicycles and vehicles, either based on an ASHTO standard or other chosen parameters? Not at the moment. We don't have that ability. I'll make a note of that request. That's very clever. The interface remembers the last speed and criteria used. So if in that case, if you don't change the speed, it'll use the one you were using for the prior movement. Can you mention about advanced layer and level definition, what that means? Yes, so advanced layer and level definition gives you essentially two choices. The first one is when you're setting up your simulation, you'll be able to match, for instance, international standards that specify that, for instance, wheels need to go on a specific layer, envelopes for the body of the vehicle need to go on a particular layer or level, and need to use this color, so on and so forth. So for those clients or agencies that ask you to submit drawings using specific label or layering conventions, you'll be able to fully match them because you can place every element on a single layer. Now, in terms of advanced, when you're generating reports with the tool now, instead of using the default layer, will ask you if you want to use a different layer. So if, for instance, you're placing a vehicle profile in your drawing and you want to specify a separate layer, not the current for it, you have control over that. We have another one. We can only make inspections of AutoTURN 11 version file that we receive. No, you can inspect simulations created with prior versions of the software because we detect all these parameters. So you'll be able to check simulations created in other versions. You'll only be able to inspect if you have 11 and Pro, though. Are any of the updates presented also in AutoTURN as well as AutoTURN Pro? Yes. All the search capabilities for vehicles and properties and well, the other features that I showed at the beginning in the list, the majority are for AutoTURN standard. In order to use the inspect simulation tool, does the original simulation need to be placed with the 2D ArcPath tool, or it can be placed with adaptive simulation? It can be placed with both. You'll be able to inspect them. Okay, let me see a couple of more questions. Will an electronic bike or scooter create a difference in vehicle movement, or can we just use higher speeds for the bicycles? that will be the way. You will essentially just use a higher speed. Not much else is really changing for the vehicle. The rider will still lean. They will essentially just drive at a higher speed. Okay, let's see more questions. Okay, so we have a question here. So you spend time developing the limits for the vehicle to fit within. Is that route saved? Yes, it is saved. Where is it saved? It's in the interface. So when you launch IntelliPad, you'll be able to see it. It can, like, you'll be shipped with the AutoCAD or the MicroStation file. However, to see it, you will need to have IntelliPad. So essentially, if the person with the person that you're sharing this file, if they have AutoTURN Pro, they'll be able to see it seamless. All you need to make sure is that the simulations are there in the drawing, and they'll be able to launch IntelliPad on their side and see it. All right. V8i SS3 is not supported by AutoTURN, so I need to stay with version 10. No, you can use version 11. You don't need to stay in version 10, but just a heads up, Bentley will stop supporting V8i SS3 at the end of this year. So we do support it with IntelliPad and AutoTURN Pro. It's just we did less testing because MicroStation is not fixing it anymore. All right. We have another one. Is it possible to adapt this simulation for motorcycles? It won't let you go at the speeds a motorcycle will drive. And right now, the tool and the speed, even though you're using the same interface, the tool and the speeds are limited to what a bicycle will do. So in that sense, you have that limitation, and you might lean less on bikes or more depending on the driving. So I wouldn't, if it's a motorcycle at low speed, maybe, but it won't be the great recommendation. AutoTURN single or multi-treated. Would more slow cores perform better than few fast cores? I think performance-wise, having more cores will improve performance. I'm not an IT person, so but I have seen kind of like dual core or multi-core works better. If I have AutoTURN 10.2 1-year subscription, how can I upgrade to my version? I'll put you in touch with our account managers that will give you options for it. We have new licensing options available to you. Is this software update available for ATO, the online version? Unfortunately not. They're different products. Online is it's more when compared with AutoTURN Pro, definitely it will be more an entry-level solution. When building custom vehicles, do you have a standard list of items to give to a client to ensure the required dimensions are easily understood and therefore more accurately built? We do not have a list per se, but essentially if you go to the software and the help file, it'll tell you what parameters you need to enter when creating a custom vehicle. What kind of fire trucks do you have in the MBL? We do have, we recently incorporated fire trucks for different fire halls in the States. We have Arizona, Texas, New York. So those fire trucks that are customized for each fire hall, we included a few of them in the current version of AutoTURN 11. We also have some European models of fire trucks manufactured by global companies, so Mercedes-Benz and DAH and some others. Can we download it today? Yes, your IT manager may have received already an email indicating how to go to my Transoft portal to download the latest version of the software if you are on MAP. Is there a reporting tool for giving clients the standards you used? You'll have to insert or place a report in your drawing telling them what you want them to show. You could perhaps do the report in a simulation, explode it, and just paste the summary telling them this is the criteria that I'll be using to evaluate. Could you decrease and increase the speed if vehicles throughout different distances while using AutoTURN? You do with the SmartPath tools. You can change the speed for different stretches. When is AutoTURN 11 released? We just did, so it's now available. If you're interested, I can put you in touch with our account managers. So we're a little over time. I think I've gone through all of your questions. I would like to thank you for attending and remind you of the survey at the end. If you have further questions, feel free to reach out to us. And I hope this presentation was meaningful to you. We're looking forward to hear from you. We have another question, I'm sorry. Will the new added vehicles available for AutoTURN 10.2? The standard, well, the database release is in AutoTURN 11. If you are on MAP, you are entitled to get the latest versions of the vehicle added if you're an AutoTURN Pro MAP. So I will recommend you to contact your account manager and ask them if you're in version 10.2 and want to have access to the latest vehicles. All right. So once again, thanks so much for attending. I hope this webinar was informative and you guys are happy with the new tools in the software. Please let us know if you have any feedback, complete the survey, and yeah, looking forward to hearing from you. Thanks a lot and have a great day ahead. Thanks. Bye-bye.